This talk is about a manifested mission that's going to be on an upcoming CLIPS flight that's tentatively scheduled for this next spring. It's called ROLSES, and it's a radio experiment for the lunar surface to investigate the electron sheath. Bill Farrell, Damon Bradley, and others are co-authors. The experiment, which was built by Goddard and recently delivered to Intuitive Machines, who are going to be one of the first of the commercial landers on the moon, is going to have two frequencies, a low band and a high band. And the low band goes to a few tens of kilohertz, and the high band goes up to about 30 megahertz altogether. The resolution is shown here, and on the figure on the right-hand side shows you the extent of the spectrum. So the proposal goal, as I mentioned before, is really to investigate for the first time the photoelectron sheath, the local ionosphere, if you will, that is near the spacecraft. There is some controversy based upon models as to what the interaction between the solar photons and solar wind and the resulting charging of the atmosphere, or charging of the surface, I should say, looks like. So there's some particular models. Andrew Poppy is a principal author on one of these sets of models. So the idea is to try to test through observations these different models of the photoelectron sheath. And one of the ways of doing this is to actually look at the plasma frequency at low frequencies, the electron plasma frequency. ROLSES is going to have the ability to be able to sweep through a large range of frequencies, and so can potentially measure the photoelectron density down to a low level. Let me just check to see if Bob has been able to connect yet and can take over the audio. Bob, have you dialed in?
He is not, but we're working on it.
Okay, let me keep going. As soon as he does, I want to turn this over to him. So here's some data from the WinWave spacecraft from a few years back, and showing this effect of the plasma frequency and being able to do, if you will, a kind of sounding of the local lunar ionosphere. In addition, there are a number of other goals associated with this mission, and I think they're illustrated pretty well here by this wonderful plot, once again from the WAVES instrument on the WIN spacecraft, and this is data when it's its current location at Earth Sun L1. You can see, for example, at the lower frequencies, the AKR coming from the Earth, and this mission being tentatively on the near side, some opportunity to do additional measurements. There's lots of RFI coming from the Earth, and we expect to characterize that. We're hoping for a type 2, type 3 solar burst. There's also the Jupiter. So lots of sources of strong radio emission. One of the things we're looking to do here is to also characterize, update the RFI. Here's another look at a so-called waterfall plot. This is frequency versus time, and all of these stripes that you're seeing going across here above a megahertz are due to RFI coming from the Earth. This is a really good illustration of why we want to go to the far side of the moon to ultimately to do low frequency radio emission. But we'd like to be able to characterize this better and look for potential holes that might exist in this spectrum, and also be able to to use a more sophisticated RFI extraction to characterize in detail the galaxy, because the galaxy is going to be a strong foreground for cosmological experiments that we'll be doing from the far side in a few years hence. An additional goal is possibility of dust detection. As was illustrated by the Cassini spacecraft, that these radio antennas are potentially wonderful dust cloud detectors, not individual particles. We don't have that kind of resolution, but clouds of dust which impact and ionize and potentially are detectable. So that is another one of the goals. So let me just put up the summary slide here. And again, if Bob can join us to help field questions, we can do that. But in the meantime, we're very excited that ROLSES is going to be the first NASA-funded radio science experiment for the surface of the moon. Has all of these goals that I've mentioned before, and we're looking forward to the launch by spring of this next year. So let me stop there.
Thank you, Jack. We have about 2 to 3 minutes for Q&A for this time slot.
I can do my best to try to answer questions, but Bob is certainly more on the heliophysics side as the expert. And Andrew might have a couple of things to say too. He's very expert and having modeled a lot of these kinds of interaction. So
I'm certainly looking forward to the measurements, that's for sure.
Yeah, so Andrew, I think this is exciting because we have an opportunity to do this measurement on the near side and then follow up with Lucy a few years from now to do a comparable set of measurements on the far side. And because the two are very different, and particularly day-night observations too, that we might have with Lucy. So this could be an exciting advance. I don't see Bill Farrell on because Bill also has been involved in thinking about these issues, particularly with respect to charging of the surface and maybe the effects on astronauts on the surface. I don't know, Andrew, if you might be able to comment on any of that.
Well, I think both the ROLSES and the Lucy investigations on the 2 different CLIPS landers will give us some nice ground truth about sort of the baseline state of the near surface photoelectron sheath and any variability. It's worth noting that both of these missions will land on the lunar surface close to or at solar maximum, which is when all kinds of interesting things happen. So fingers crossed for interesting events, but I think that'll provide some nice ground truth data to compare to some of these models, absolutely.
So we'll have to see also if we're going to be lucky as to whether or not there will be a type 2, type 3 solar burst associated with CME. We're moving towards solar maximum, but not there yet. We're still a few years away. And it would be nice to be able to have that recorded event from the surface as well.
Jack, could you comment on when it's deployed, how far away is the instrument from the lander?
The instrument is right on the lander.
Right on the lander.
Yeah, it's so going back to that cartoon picture that I showed earlier. There's 2 sets of dipoles, one here in blue and another set that's perpendicular at 1 meter above the surface, and then the spectrometer, the radio spectrometer, is inside and has somewhat of shielding from the heat of the day.
Thanks.